Welcome to Ask and Learn.
So here we can see that the domain is x is all real. And for the intercepts, if we factor this out, we have x to the 1/3 times x to the 2/3 minus 3 equals 0. So we have x equals 0, so we got 0, 0. And we also have x to the 2/3 equals 3. And that's the same thing as x equals 3 to the 3rd to the power of 1/2. So we have x is equal to plus or minus 3 square root 3. So our second intercept is plus or minus 3 square root 3, 0. And for our symmetry, we can plug in 1 and negative 1 for an easy way to tell what it is. So we do 1 minus into this function, 1 minus 3 times 1 to the 1/3. That gives us negative 2. And we plug in negative 1 minus 3 to the negative times negative 1 to the 1/3. And that's positive 2. So they're the same number but opposite signs, so this is odd. And for asymptotes, none, because it's not rational. And now, to find the increasing and decreasing values, we find the first derivative. So the first derivative is y prime equals 1 minus x to the negative 2/3. And if we set that to 0 to find the critical points, we have 1 over x to the power of 2/3 equals 1, or 1 equals x to the power of 2/3. So x is plus or minus 1. So that's our critical points. And let's also find the second derivative while we're at it. So y double prime is equal to 2/3 x to the power of negative 5/3. And if we set that to 0, it looks like 2/3, let's make it bigger, 2/3 x to the 5/3, all on the denominator, equals 0. And we see that y double prime is undefined at this point, at 0. So we're going to say it's an inflection point. All right, and now if we draw our line, and we put negative 1, critical point, and then also 1, and then we put our inflection point, 0. So let's say this is our inflection point, 0. And we're testing f prime, we're doing the first derivative test. And we can see that this is positive here, negative here, negative here, and positive here. So from positive to negative, increasing, decreasing, so this is a max. And here we have since it's negative to positive, this is a min. So here we have our min. This is the first derivative test. And also we can see what the y values are for those at f1 and f negative 1. Here we have negative 2, and here we have 2, like we stated earlier with the symmetry. And f of 0 at our inflection point is 0, and we know that's an intercept. So now, and we also know that y double prime at 1 is greater than 0, so this is concave up. And y double prime at negative 1 is less than 0, so that's concave down. And now we can graph it. So we know we have an intercept at negative and positive 3 square root 3. And 0, 0. So we have an intercept here, here, and here. And now we see that at -1, we have -1, 2, we have a max. So this is 2, and let's say this is -2. So here we have a max. Oh, let's say this is -1 and this is +1. Oh, my bad. -1, +1. And here we have a max. And +1, -2 is a min. And we see that it's concave up here. Here's our inflection point, and it's concave down here. And this is our graph.